Hello all, we are live, so you can start the session.
Hello, everybody. I'm not sure how many participants have logged in, but welcome to the live session of our additive manufacturing course that we are um, offering. Hello, everybody. Um, right. So I see that there are no students, I think. That's what Ayush is saying. So should we wait for maybe some of the participants and students to join before we start? Sure. Uh, Ayush is saying we can wait for 5 minutes for others to join, so we can do that. Information, myself and Leela Krishna are joining from the same room here in Wipro 3D. So the audio that we will be using will be from Leela Krishna's computer, and we will be on mute till we have more students joining. Yes. Hello again. I hope we are audible and that we are visible. People may be slowly joining, maybe the Zoom call and maybe on YouTube. So I'll just get started with kind of outlining the program that we offered. and then we can take any questions that the students would have. So we've offered the 10-hour program on the latest trends in additive manufacturing. Now, during the first few hours and the first week, what we tried to address is the fundamentals of additive manufacturing. So the intention over there was to um, familiarize everybody uh, with the technologies that come under the category of additive manufacturing. So very often we will know one or two or three additive manufacturing technologies, but in reality there are seven different categories according to ASTM, and there are a lot of variations even in those seven categories, right? And at times it can get confusing and overwhelming, but it is important to understand them so as to know which is the correct technology to use for an application that you might be working or for a project that you are doing. Hence, the first week was more about how additive manufacturing evolved, the history of additive manufacturing, why should someone use additive manufacturing, as in what are the different value additions that additive manufacturing puts on the table, and then we look through the entire additive manufacturing technology landscape. We did this starting with some of the known technologies for printing polymer, and then we slowly moved on to some of the technologies with which can print with metal. Other than metal and polymer, of course, there are other materials that can be printed as well. Now, every time we covered these technologies, that is, be it polymer or be it metal, what we have tried to do is staying true to the name of the course that we have given. We have tried to give you the a picture of the latest happening in those technology processes. So we have explained a lot of processes which are very new, whose working principle could be a hybrid of different technologies or could be completely new process that is being followed. All of these newest trends and developments in the technology were discussed. Moving on to week number 2 and 3, there what we did was we then discussed the the software control part of it, monitoring the process, designing for additive manufacturing. So we looked at a bit of the extended workflow, not just the printing process. And even in those sections, what we made sure was that we communicate to you what are the latest advancements in software? Is AI and ML being used in these softwares? How is the process flow being simplified using all these tools? These are the kind of topics that we discussed. Now, all of this data that we have been sharing are from market reports and various other reports that are available. And of course, some of them are based on the latest research papers as well. So what you have been informed about is not just what's existed for 20, 30, or even 40 years, but what is happening right now and what is the future possibility. So when we discuss these trends that are going on, we were hoping that we will also be able to communicate to you as to what is the next big thing that you can expect or do coming up. Then we moved on to materials. We covered polymer materials as well as metal materials quite a bit in detail. Again, staying true to the topic, the name of the topic. Even in materials, we have had a section where we have discussed the latest materials that have been included into the portfolio of additive manufacturing. And I think the course would be completely incomplete if we did not discuss the applications or the case studies that have been the talk of the town, I can say, using additive. So what we did there also is we took a very systematic approach, and we said industry wise we will come out with case studies which have been trending, which have set the tone for that particular industry, and we discuss case studies in each of those industries. Now, if you look at some of the industries we covered were like medical and aviation, which are extremely regulated industry. So you need to do a lot of certifications, qualifications to get use cases over there. We've shown those, and we've shown not so serious case studies as well. The idea behind this was to again inspire and hope that you get more ideas as to what are the different kinds of applications that can be developed using additive manufacturing, and also to kind of instill a confidence that industries around the world are using this technology to make not just prototypes but also end use parts, be it in batch production or mass production, right? So the maturity level of the industries and the market is also something that we wanted to showcase through the case studies. So this is how our 4 weeks looked. And now I can probably take a pause and see if there are some questions for us to answer. So what I understand is that there's not many questions on YouTube. So I might have Dr. Alankar also on the channel. So while we wait to see if there are any questions, Dr. Alankar, you could also add a few things about the course if you wish. Ayush, I see your hand is raised. Would you like to speak or uh, put up your question on YouTube or here in Zoom?
We have a question in the response sheet.
Mm-hmm.
Hi, can you please throw some light on advancement in 3D printing, laser powder bed fusion, done by firms like Vulcan Farms?
Mm. Can you please throw some light on advancements in 3D printing, laser powder bed fusion done by firms like Vulcan Farms? I'm not in particular familiar with Vulcan Farms. And I hope I am audible because I'm using Krishna's audio. But yes, the latest and the greatest which is happening in laser powder bed fusion is definitely to make the machines bigger, to make the machines faster. This is the intention. As in, we want to print bigger and bigger parts. So one of the few things that is being done in this regard is that we're adding more lasers on a machine. So two was very common, four was there, but now you have six, 12 lasers on a single laser powder bed machine, which then can cover a larger area while printing. Hence, the size of the parts that can be printed is also increasing. To increase the speed of printing, I think Dr. Alankar also addressed this in his session. What we are trying to do is do area-wise printing, as in expose more of an area rather than have just a laser point melting only a very small area. So that's also something that is happening with laser powder bed fusion. But if you look at the whole workflow, then definitely what is happening is more automation in terms of file preparation. So how to orient the part, how to give support to the part, what type of support to give. This kind of automation is happening when we look at file preparation and the monitoring, process monitoring. That's also a very, very big advancement. Now, to prove the quality of the part, to prove the control that one has on the process, like LPBF, so that it becomes easy to certify and qualify these parts, process monitoring becomes very, very important. Hence, a lot of advancements are being done in terms of monitoring the process itself. Then if I think about after the printing process, there is post-processing also involved. So we've stressed quite a bit on how important post-processing operations are for especially metal parts, right? So automation of these post-processing operations, like let's say powder removal, support removal, and these kind of things is also something that is happening. Even though directly not connected with laser powder bed, it's a very, very big part of how it is adding value to the process and how the process is becoming more and more efficient. So I hope I answered the question. I'm not sure who asked that question, but a really good question. Would there be any other questions for us?
Gaurav says thanks, madam, in chat.
Okay, then probably that was Gaurav's question. I hope I answered it. I'm not very sure who or what Vulcan Farms is, so I'm sorry I couldn't answer that in particular to them. Any other questions? Krishna, so before we get more questions, if you would like to add anything about your sessions that you gave.
Yes, sure. So on the week 2 session, we have mostly seen about what are the different softwares which has been used at different steps of additive manufacturing that we have seen. And mainly on part identification, there are some new softwares which are coming up, and we could see some softwares like Caster, Select AM, and Octane, Cognitive Additive. So these kind of even 3D Spark. So these kind of people are could able to utilize some CAD files in identifying which type of AM technology can be chosen, and what would be the lead time, and what would be the cost, and whether it is feasible to get it 3D printed or not. So these kind of insights these softwares could able to give us. And we have also seen some order management system kind of software which are similar to what we have seen in e-commerce websites like Amazon or Flipkart. It's a similar kind of thing, but there should be some change. It comes when it comes to the additive manufacturing, because the code creation, that is automated code creation, is like a different kind of scenario when it mainly comes to additive manufacturing. So that also is being taken care when it comes to this order management system software. And we have seen this design and optimization related things for quite a long time before also. Things like doing some lattice generation, and also things like topology optimization, generative design. So these kind of things are mostly like available in the current software, like CAD modeling software, like Fusion 360 or SolidWorks, like Dassault Systems products. or otherwise Siemens products or even Ansys products, we could able to see these kind of tools are available. And later we have seen about build preparation, where still many softwares are trying to integrate the complete ecosystem of 3D printing into them. So say things like fix and edit, support generation, orientation, these kind of things are already available in softwares like Magix and NetFab, but still they wanted to integrate this with their CAD packages, as well as they would like to bring it to the next step by adding the build processor with it. So these kind of steps make it much easier when it comes to additive manufacturing. And later we have seen about process simulation, which is way more critical when it comes to large format additive manufacturing or LPBF technology, kind of technologies basically, like where too much of money is involved in getting the part printed. So those places we could see the involvement of process simulation, where we could able to detect the defects which could happen during the printing process. And when it comes to LPBF, we could able to see some distortions or residual stresses. This can be detected during the printing process itself. And again, we have many such softwares for doing it. And people are nowadays using artificial intelligence also to detect the defects and a very high level. And we have build processors which mainly consider all the printing parameters and generate the toolpaths required for the machine. And this is currently like um, differing based upon the technologies also, and from machine manufacturer to machine manufacturer. But here also, as like a CNC machine, this could be developed in a generalized manner in the future. So that might be a possible thing. But still, like each and every technology will require different type of tool path generation setups. So we expect some big change that could happen. And when it comes to build processor itself, the parameters has to be identified properly. Like we have to run multiple experiments to identify these parameters. For that purpose, many companies are working on it. And we can see about printing technology and process monitoring, where on real time the process can be monitored for any defects, and that also we have seen. And many companies, like many software providers, are available for that to be done. And finally, we have seen about the manufacturing execution system. This is not a new thing in the current environment, because already the existing manufacturing and production setups use this kind of software tools. But this has to be tweaked a little bit for the purpose of additive manufacturing. Those processes also need to be involved in these kind of softwares. So, like we have seen materialized co-AM, collaborative AM platform, and manufacturing OS. So these tools provide a good amount of MES facility for additive manufacturing. And this is what like we have seen in the week 2 lecture on developments in design and process monitoring and control.
That's a good summary. Thank you for that, Krishna.
Yeah, if you have any particular query regarding related to this, or any other things related to the softwares, you can please post it in the YouTube chat. We'll be available to answer your queries.
Also, happy to share our experience.
Yes.
And so we've been in the business of 3D printing for about 12 years through Wipro 3D. And in case you want to learn more about our experience, what we face, what we think, please feel free to put your questions in the chat. So meanwhile, when we wait for those questions, maybe Dr. Alankar, you can also give a quick recap on the sessions that you lectured on to the audience.
Sure, Akshata. I think I'm having a lot of background noise here. I'll take just 5 minutes to move to a better place.
Okay. So I think there's another question, which is, would you be able to throw some light on application of additive manufacturing seen in defense applications, especially in Indian context? Again, a very good question. I think historically, it's always been the case that the most newest and latest technology is always adopted by the defense, right? So if you look at telephone, if you look at internet, these were all technologies that were first adopted by the defense sector, and then space, and then it comes to aviation, and then it becomes a household name. So additive manufacturing is no exception to that. It is a technology that the defense sector has been using quite a lot. The defense sector has been using additive manufacturing for various things like repair. Repair is a very big application. So whenever they want to repair, let's say, an impeller or a broken part, they use it a lot. Of course, now to make new parts as well. Also, there are some examples where they have tried to print on a ship or on a moving ship. So these kind of examples are there. Now, when we come to the Indian context itself, I think they have done really good work. Whatever I explained just now, as in using additive manufacturing for repair applications, using additive manufacturing for making new parts. In fact, during COVID time, the printers that were there with the defense sector, I know that it was used to make these safety keys and things like that as well. So those are all there. So everything that's happening around the world is being used even by the Indian defense industry. But something unique that our defense has done is they've constructed apartment somewhere in Gujarat, if I'm not wrong. It is a two-storied apartment, and I think it was completed in 11 days or something like that. So concrete printing is also something that they have explored. Polymer metal, of course, yes. And I'm sure they're doing a lot more. And there are a lot more things that they will not be able to share publicly. And hence, we would not know of it as well. But yes, defense sector, be it Army, Navy, or Air Force, all of them do use additive manufacturing quite extensively. And I think Make in India, indigenization exercises that are going on in the country is also a big boost for them to use additive manufacturing for spare parts, obsolete parts. If you would have attended the first few sessions, you would have seen Dr. Alankar talk about how it can be used to make parts which have been obsolete, as in you don't have any suppliers for it anymore. You're not able to get that part from anywhere. And you can reverse engineer and then make the part additively without investing in any tool. It can also be used to make spares on demand. So you don't need to order, let's say, 100 number of spare parts when maybe in the year you use only 10. You can order it in smaller batches when it comes to additive manufacturing, right? So these are all some of the areas in which defense is using additive manufacturing. Um, Hence, the value adds also will be aligned to that. Shorter lead time, maybe lesser price, flexibility in production, new designs, more efficient designs. These kind of value additions will be there. And of course, material wise, I think they're very, very innovative and using quite a lot of materials. And I hope that this question is also answered. If there's anything more specific you would like to know, please feel free to put it in the chat or the response basket.
So I would like to add to this, Akshata, would it be fine to
Yeah,
answer the same question?
absolutely. Sure, sir.
So yeah. So in defense, like many other industry and domains, there are some mission urgent needs. For example, during war time, we cannot wait for inventory. We cannot make the part to be transported to the site where the war is going on. So additive manufacturing is being used for manufacturing on site as needed immediately. Many countries have demonstrated it, and especially using additive manufacturing, since parts can be developed using multiple materials. So, on-site design and immediate manufacturing becomes very easy. Especially in defense, this lightweighting of structures is very important. And as also described in the course, using additive manufacturing, we can immediately design innovative parts and can manufacture them, right? So, for example, one critical application for which the solution is currently being sought is the design of armors. So for armors, we are looking for either solid light materials or lattice structures, right? So depending upon how much impact energy that a structure can absorb, on that there is a lot of research going on. So that is one of the major applications in defense. Also, like in aerospace industry, in defense also, the engine design is a separate topic where a lot of additive manufacturing is being applied and being used. India itself is working on design and manufacturing of its own engine, and there is a plan to apply additive manufacturing in those parts as well.
Yeah, those are great inputs, Dr. Alankar. So maybe I could answer some questions regarding the assignments and the study material. So over here, yes, the assignments were in a way designed so that you can go and explore a lot of new technologies and new processes or variations in the process. So during the lectures, what we discovered together was that there may be different acronyms, different names to the technology, a slight variations in the name, and maybe a small tweak in the process itself, right? So these tweaks are there, which bring in the variations in different processes. Now, what we wanted to do in assignment one was that we wanted you to explore these variations, and hence what we did was we gave you a small lead, and we gave you an acronym wherein you could go on Google and simply type that and just say additive next to it or 3D printing next to it, and then what you would get is probably the full name of that particular acronym, full form of it, and then you would have to go in and see, okay, so which company is claiming to make a machine which works on this technology, and then you would have to explore how does this technology actually work, as in what is the form of raw material that is being used for this particular technology, and then what's the working principle, how is it changing its form from the raw material to the final part, and then you would be able to map it to one of the 7 technologies that we have already discussed, right? So that is how it is relevant to the lectures that was provided. So if you have understood the lectures well, and if you have no doubts there, then you would be able to, upon reading of this technology, be able to map it to one of the 7 technologies. So that is assignment number one. And Assignment number 2 and 3 are more multiple choice based question. So was week 1, but this is more of material that is coming from the lectures that were provided itself. So those would be relatively easy if you looked at the videos. And then the week 4 is much more kind of creative and subjective. So what we would like to understand is for you to go and explore what are those case studies which exist there in different industry verticals, and try to see which technology was used to achieve this, or was it in metal or polymer or some other material which is quite new and not just metal or polymer, not like that, right? So this is more subjective, where it will give you a chance to explain your thought process about how additive manufacturing can be applied in different industries. Now, the variety of material that you can refer to for most of these things should all be available on Google. So we've made sure of that. AM Power is a website who have a lot of infographics, and yeah, they have a lot of white papers and things like that that you can refer to. So you could use that as a reference also. That's a good reading material. But you see, when you look at case studies, or when you look at specific technology and OEMs making machines of that technology, what happens is that you will have to read up material concerned to their company itself, right? So this would not be available in a research paper, or it would not be available in a book, so as to say. So to find this kind of latest market and industry related data, you will have to go on Google, and then uh, start with a clue, which is usually the question that we have given. And then from that question, when you start to search, you will get led into the correct company or use case or a technology. So feel free to just go on Google and use these things. AM Power is also another website. You can come to Wipro 3D website as well, and we have some case studies on that, some reading resources. You can make use of it, and that will be very helpful for you to answer your assignments, right? Then I don't know if there would be any other common assignment questions uh, that I can answer, but yeah, I hope that this tip helps you to go and finish the assignments. It's a lot of fun. I think a bit different than just the normal MCQ where you have to go and read up. So please give it a try, and let us know how it goes.
So I'm not sure, Akshata, if we have addressed the resubmission policy. Do we know about it?
I am not sure, sir. If you are, maybe you
I
could.
think, so we'll get back to the students probably after discussing it with NPTEL, what
Mhm.
is the resubmission policy. As long as I know, once the deadline is over for us and for an assignment, the resubmission cannot be done.
Okay.
Yeah, but we'll get back. We can post it somewhere on the course webpage.
Mhm. So I guess while if there are more questions, maybe Dr. Alankar, you can now uh, give a recap of your sessions.
You are speaking with me, Akshata. I see. The summary of my sessions, right? Okay.
Is it okay now?
Right. So I started my lectures with the history of additive manufacturing, in which we talked about how over the decades additive manufacturing has taken the present shape and how it has evolved with the industrial revolution, and what is the current state when we are talking about industry 4 and amalgamation of AI and additive manufacturing, how automation is participating in additive manufacturing. So a summary along with the history was given in the first week. And the most important thing is that in the same week, we also understood what is the value addition. This is the first question that we ask often, that whether we should choose additive manufacturing or a traditional method for making the object, right? So whether it is the high value product, or are we going to make just one instance of the product, or are we going to repeatedly make it based on that, or how additive manufacturing is going to contribute to the value of that product and application. Based on that, we make a choice, and several items, several point of views were discussed there. How additive manufacturing increases the value or has some advantage over the traditional processes, for which type of applications it should be used. Then in week 2, I focused on what is powder bed fusion, what is direct energy deposition, what is sheet lamination, and various hybrid technologies, which are proprietary technologies used by various industries. And some of these processes were already described as part of PBF and DED. However, some are very innovative, because based on the application, there are minor changes in the principal processes, and they are applied to specific applications. For example, development of the medicines using additive manufacturing was also described. Then we had a topic in week 3 about which various metals are used in additive manufacturing. And then there was also development of various metal powders, and what are various measures based on we decide whether that powder is suitable for additive manufacturing or not. What are various processes to create those powders and their various specifications, what are defects in metal powders, etc. What are the recycling conditions and criteria when you buy a metal powder? What should be the quality checks that one should look at before making use of the powder? In the last week, we looked at various case studies, and I think this was the most interesting part, because it put all the content that we had in week 1, 2, and 3 together. We were able to see direct applications of it. So we were looking at applications, how applications are decided based on design, or how materials are chosen, how multiple materials are chosen for various applications, and across span of applications in oil and gas, automotive, uh, even in construction, we saw various examples of these additive manufacturing processes. We also saw applications in consumer goods, and those are the items that we often come across, right? So we were able to relate it, and I hope those case studies were good enough to make you realize that additive manufacturing may not be giving you solution for everything, but it is definitely giving you a solution that traditional manufacturing for certain applications cannot provide in a given time and given the design. So if you have any questions related to those topics, you can ask now.
That was a great summary, Dr. Alankar.
Thanks, Akshata. Are there any questions, Ayush?
I guess if there are no more questions, is it safe to sorry, is it sorry about that. Is it safe to think that we could end the live session?
Okay, I think we can close. Yeah.
All right. So maybe on a closing note, a thank you to all the participants who took the time to look at the course content. Please let us know for any questions or clarifications that you would wish. We had a lot of fun curating this course for you. Your feedback will only help us improve it according to your requirement and needs. So thank you, and I will let Krishna and Dr. Alankar also put some last closing words.
Yes. So it was a great lecture that was taken, and we really look forward for your feedback on improvising this course to a very new levels. And thank you very much for giving this opportunity and like giving to Alankar sir.
Yeah. Thanks, Leela. So for us also, it was a good learning experience. Curating a course for a very wide audience, which may have very different background, and that too via online platform where there is no in-person interaction was a challenging exercise. But I'm very happy that except a few learning experience like how to put assignments together and so on, I think we did a decent job, and would love to hear the feedback directly also if possible. And I hope the students will be taking this course in future as well. And I think this also gives us an opportunity for the audience to connect with Wipro 3D and IIT Bombay for research and applications. Thank you so much.
Thank you. Bye bye, everybody.
Bye bye.
Okay, thank you all. We are closing the session.